So students, Eric Magidson here. I just wanted to provide a feedback video on the week 5 participation assignment, all right? First of all, how you'll be graded, how much content do you have here, how much work did you do, are you making statements that are true, or in fact, did you put data that is false, okay? So something to consider. And then we'll talk about the critical thinking question at the end. I don't want to spend a lot of time up here. I'm trying to make a short video that people will watch. The fact is, folks, in the learning cycle, the feedback that you get from me is teaching you what you did right, what you did wrong, as well as maybe teaching you things that the course outcomes didn't teach you that's of value. So I really hope you're watching this. We'll talk about if you are watching this in just a minute. But so here's the deal. Some of you may have figured out there's Wi-Fi 6. There's actually Wi-Fi 6E, which falls in between there. Wi-Fi 6 uses 2.4 gigahertz, 5 gigahertz. Wi-Fi 6E adds 6 gigahertz. Now, all I want to say about gigahertz is this. When we have lower gigahertz, our signal transfers further, but it's not as fast. When we have higher gigahertz, our signal goes not as far. So like 2.4, I can reach my network at my neighbor's house. 5 gig, I stop reaching my network in the middle of the street. However, this will only transfer so much data. This transfers way more, and this would transfer way more, okay? Then we get down to maximum speeds. These are what they are. 9.6 gigabits per second is what they estimate the high speed to be. That's marketing terms. This is the expected speed. This is actually what you should expect to get if you have Wi-Fi 7, okay? Then we talk about what makes this all work. It's 1024 QAM. 1024 QAM, okay, data rate increase in Wi-Fi 6AX, okay, access points and devices, 25% data rate increase. So this technology, this protocol does this. Then what we did is we jumped that up from 1024 to 4096, okay? So better quality even more. What does this mean? Well, down here we use 8 streams to transfer data back and forth. Here we use 16 streams, but here's the cool thing. With this protocol change and more efficient protocol, if we go from 8 to 16, that's 2 times. But notice this actually provides 4-time increase in speeds. Why? Because the protocol has been made more efficient, plus we're using more radios and etc. Now let's get down to the real meat and potatoes. Here is the critical thinking question. If you primarily used their Wi-Fi to connect to the internet and not transfer data within their Wi-Fi network, would they still want to upgrade their equipment? Now, there is a correct technical answer, and the answer is it depends on what the bottleneck is. The bottleneck is the slowest speed in the process. Well, let's take my internet, for example. I've got 1 gigabit per second download speed and 20 megabits per second upload speed. Well, do I need a modern router and Wi-Fi that does 9.6 gigabits? 10 times the speed of my internet connection? No, I don't. Because this becomes the bottleneck right here. Now, if I had a 10 gigabit fiber optic connection, then suddenly, if I have my old Wi-Fi 5 router, which only supports about 1.3 gigabits per second transfer rate, then this device becomes the bottleneck. Because I have a higher speed, I'm going to lose speed that I'm paying for because my device doesn't support it, and then I lose speed into my local area network, which is right here. Okay? Now, if I'm transferring data in the network, which means I have a smartphone and, say, a computer here, and they both talk in Wi-Fi 6, then they're going to talk at 9.6 gigabits per second. So if I have a media server, then they're going to talk really fast. The fact is they're talking over the stream rate of videos, which we'll look at in just a minute. So first of all, if you're watching this, okay, tell me, send me an email, CIS120. I reviewed week 5 feedback. And then tell me something you learned from the information that I've given you here. Okay? We'll close the loop with learning even more. And if you do that, you're going to earn 10 additional performance points for learning more. So you notice this is the bottleneck here. Well, here's something you may not know. Netflix, a steady internet connection of only 5 megabits per second, not gigabits, but 15 megabits per second is needed per stream for high quality 4K streaming. Just 15 megabits for each stream. Got 5 people in the house, multiply by 5. That's the bandwidth you need just for Netflix. Okay? Call of Duty Warzone uses, now we're talking data, not speeds. We're talking data. But you'll notice it uses 175 meg of data per hour, or 1 gig of data equals more than 5 hours of playtime. Well, if I'm playing for 5 hours, I'm using a gigabyte, 1024 megabytes of data. The faster connection I have to the internet servers, the faster that data can be transferred to my computer, the faster I can play the game. Okay, so hopefully that makes sense. Hope you enjoyed this video and that you're learning a lot in the CIS 120. Take care.